Schönen guten Morgen, miteinander. Welcome everybody. Now we change language. Most welcome everybody to this, actually we can say, second National Day that we have. Because it's a very special moment this morning that we can spend together. And on behalf of the Swiss Academy of Sciences and also of the Academies of Arts and Sciences, I would like to welcome you most warmly to this wonderful moment that we have with us, Thomas Zurbuchen, the director of the NASA Science Mission Directorate. That's the correct expression, I believe. Our man in the space and in the USA, but actually having deep roots in our country and not losing the roots, because I understood that yesterday he actually, in his home place, he gave the 1st of August speech. What he said and what, that's not the matter now, but the interesting thing is really that he came back to the roots. And this says what we often know also and realize in our life: no roots, no fruits. And this is wonderful that you came and that we also have this opportunity to welcome you here at the top of the University of Bern. I think you can't go higher in the University of Bern main building, and to have a stimulating morning. The morning is not to debate the greatest things in science, but it is to get more stimuli from the work you do, Thomas Zurbuchen, to us, to our science community interested in the field, to stimulate also, as we will see, the young scientists, the upcoming generation, actually to see what really matters, and not just hearing NASA and seeing satellites orbiting around, but really actually understanding what is all for. And this is the wonderful moment for us. And that's my only function I have, to welcome you and to wish you a very nice morning. And the rest will be in the hands of the moderation by Beat Glocker, who is the one who is actually deeply rooted and committed in science, but always coming from communication, journalism. And this has also, he also has deep roots in the field and in what we do and what we are here for. So I really would welcome now, please, Beat, to take over. And Thomas Zurbuchen, you are so welcome.
Thank you. Thank you, Marcel Tanner. Marcel Tanner, the president of the Swiss Academies of the Sciences. And I welcome Thomas Zurbuchen. Presenting him is in vain in this audience. For this audience, I just would remind you of these facts. Thomas Zurbuchen directs about 10,000 co-workers. He has a budget of about $6 billion, almost. And he is the head of 104 missions. I do not dare to ask you to name all these 104 missions, but he is he's our man in the moon, our man in space, our man in the United States. But please, Thomas, come, and I dare to ask you something. Give him a warm welcome.
Thanks.
In contrast to Marcel Tanner, I'm very curious to know, what did you tell people in Heiligenschwendi yesterday to the 1st August? What was in a nutshell, your speech?
So, you know, I'm like all of you, or most of you, have a lot of gratitude to Switzerland. And I was, of course, talking about that gratitude. Also, the picture I have of Switzerland from the inside and the outside. And frankly, the short and the long is Switzerland is a lot better than the self-image of Switzerland. I mean, you know, from the inside, you know, you're often very critical. I open a newspaper, it's very critical. The outside image of Switzerland is extremely positive. So that's the first point. The second point was about really my experiences of what it takes to learn how to do science and how that can be applied to keeping the freedoms that are there, and that is to actually turn off all the handy, as you call it, the mobile phones and the television, and think. It's really important to think. The second one, it's really important to ask questions and insist on simple answers that you understand. Because if you don't understand the simple answer, very likely the person who gave you the answer does not know the answer. And so ask more, not less, if you don't understand.
Well, Heiligenschwendi is not a big town. It's
not at all.
It's on the countryside, a small village. How did they react to your message?
Yeah, they were. Many of the farmers came and told me that they really appreciated it. They appreciated the personal touch of my interest in Switzerland directly, but also my excitement about nature. And they told me that they have the same. See, it doesn't take a PhD or a high degree to love nature. I love nature, and that's why I do what I do.
Mm-hmm. And in many portraits I read on you was the Heiligenschwendi termed something holy, Heiligenschwendi. What do you think? Why is it so attractive for Switzerland to have the NASA director coming from Heiligenschwendi? I dare to say, if you would come from Zurich or from Bern, this wouldn't be of interest. Why is it so interesting? The man at NASA from Heiligenschwendi.
You tell me. I don't know.
I didn't know.
I don't know. It is the fact that a child growing up in a city who's is born to a parent of somebody who went to university like this one or elsewhere is much more likely to go to university as well. I did not grow up in an environment like that, and so for me, the fact that I am where I am is a testament to the educational system, whether it's in Heiligenschwendi or in Thun or in Bern or in Zurich or Basel or wherever it is. So it's the educational system is really strong, but I think it makes a better story.
It's a good story.
If you come from a place where you're less likely to be expected to do that.
I would say if you were born in Trubschachen, it would not be as attractive as Heiligenschwendi.
Harder to pronounce, yeah.
and
like
in Heiligenschwendi you have the holiness. And I mean, space research and NASA has nothing to do with holiness. Perhaps this would be the secret of that attractivity.
Could be.
Okay, now we step further to research, to science, and give Thomas the opportunity to present as his keynote. And you see, he has no PowerPoint, no electronics. He turned his mobile phone off, and he will talk on 6 posters. He will take us on a journey with few of the spacecrafts. Voyager, which is the most remote man-made object. It's actually in the intersolar space. Parker, who will explore, who will touch the sun. Cassini, who is on its final countdown, so to say. Then Hubble, the famous, is this Nicoli on the
exactly
picture?
Right.
Yeah,
you got it.
And if you look very closely, he is smiling. Yeah, I blew it up on my laptop, and he's really smiling.
That's right. That's right.
And then Messenger, who will be launched.
Oh, it's already crashed on top of the planet 2 years ago after a successful mission. So it was launched in 2007 and did its mission.
But you were...
Pepe Colombo is being launched. Where are you? Nick, where are you? Oh, there. Yeah, so Pepe Colombo is being launched in October, most likely. We're going to have to figure out who's launching first.
You've been involved in the...
Absolutely. I built an instrument on that one. Yeah.
On that one. So, and you give us now the opportunity to travel with you across space.
Perfect. Yeah. Let's see. Thanks so much. So what I'm going to do is to talk about what it takes to make miracles happen. Some of you are building companies. Some of you are innovators. They're doing fundamental research. Some of you have big goals. Perhaps it's in making the world better through actions that you undertake. And so basically, what I'm going to do is talk about the really hard task to do this. I'm going to kind of start with a technical front end, but then really talk more about the personal side of what it takes to make miracles happen. And the way I'm going to do that after I do this introduction is I'm going to really tell 5 stories. Because, I could, by the way, I could give a similar talk, and I have, about companies. I could do a similar talk about some other type of set of innovative solutions, but I'm going to take those 5 to kind of just really talk about what it takes to do fundamental research, which is a real adventure, or what it takes to build a company, or everything in between. Make sense? So what I'm going to do first is respond to a request that I got, which is, hey, tell us about how NASA thinks about innovation and technology transfer. So that's what that poster is about. And so basically, what I'm going to do is talk to you about the research that we're doing, and I use examples of missions of how we do this, and I'm using a chart that comes out of the business world. Normally, what is down here is the market impact, and what's up here is the technology, the kind of depth of the technology transformation that's going. It's really important to look at this way. So in the program that I'm running, close to $400 million per year, we're investing in just technologies that are related to science. And we really do this in 4 buckets. It's really important to think of these buckets as such, because if you have to manage each one of the buckets differently. So the most important one, and when I say incremental research, what that basically means to many is, oh, it's not really exciting. Well, incremental steps, even if we want to be breakthrough innovators, even if we want to be game chambers every time we start our computer or we come to work, the fundamental fact is we don't have the capability of doing that. If in your life you have 3 to 5 major innovations, you're a really successful person. So, but most of the progress, most of our missions that we're doing, and here I put TESS, which is a terrestrial planet finder mission, I put there. Basically, the mission that's going to go there is going to find more exoplanets. In many ways, in partnership with your mission, HEOPS, that's going to come later. So if you looked at that mission and you take it apart and look at its part, almost nothing on that mission is new. Almost nothing is new. But it's turned into a great system that does the very purpose that it's designed to be, which is to be an explorer of exoplanets, new exoplanets. And so the incremental, innovation, of course, does not involve a lot of new technologies. It's not going to really change the world, but it's absolutely essential. Every time we turn around, we want to make sure it's a little bit better. Switzerland is great at this. What I have here is, at the beginning was, breakthrough innovation, but it's really that kind of steady progress of material science, steady progress towards an excellent product. That's what it takes to incremental kind of innovation. The breakthrough innovation up there is an innovation which is showed here, which does not have a lot of program impact. So it's pretty narrow, but it has a huge technology step. So it's really a fundamental new improvement of a technology to do something very, very well. This one is SWAT, a mission that we're doing together with our international partner, and it's using a totally new approach to map the ground, a totally new approach to do earth science. And this was developed in technology investments earlier on. Now we're building the mission, and it's promising to really transform our understanding of that aspect of earth science that we're going to investigate. Many of our investments are there. James Webb, the biggest telescope that we're going to fly, well, it depends on who goes first, right? October or after you. I don't know what you saw. The press yesterday came out that we're sitting on top of each other relative to the launch. James Webb and Pepe Colombo. We're going to figure it out. It's no problem. But a lot of the investments there, we had 10 new technologies that we invested in, but they're not really useful much more broadly than for big telescopes, but they're up there. We have new material science, we have new thermal systems. That's what we're doing. So here, this is a really expensive innovation process, it turns out. It's almost like innovate through the wall. You basically say, I'm here today, I want to be on the other side of this wall in 5 years, spend money, go through the wall. So that's what that type of innovation is. Every once in a while, that's exactly what we need to do. Game changers are really rare. Game changers are innovations, and of course, you have some of them in your pocket. It may be your iPhone, it may be, chips that were developed for totally different purpose. But what happened to these game changers, it was advanced technology, and it changed everything. And so what we're doing here is deep space optical communication. I'm using that as an example. So we're investing in that technology, and actually we have already, now we're putting it on the first mission. I selected a mission that's going to go beyond the asteroid belt and will map, send down the data using lasers. If that works, everything changes. So basically, not just for these missions, we're going to start using this everywhere, just because it will increase the downplay, per watt of power up in space. We can get factor of 10 or more bits down to the ground. For Earth science, absolutely crucial. A little slightly different technology from deep space, it's transformative, especially if you want to go hang out at Mars. So it's absolutely important. Disruptive innovation is a really counterintuitive one. And it's counterintuitive because it has huge, as you see, impact, but very small technology. I'm going to talk to you about my laptop, the first laptop I ever had. First laptop I ever had, I had because I wrote my PhD thesis in the neighboring building here. And frankly, I hated writing. Actually, I hired a writer to help correct my PhD because, I spoke English worse than I do now, I would say. But the bottom line is, I bought that laptop, and within just a few months, it burned up. It was slower than my desktop. It was not well designed. There were horrible problems with laptops. But I went and bought one again. Why? It's because I wanted to write my thesis in a ski resort, not in the office. So having a portable computer was all it took. So even though the machine was worse than the machines that were in the marketplace, I bought it. The same is true with your iPhones. At the beginning, iPhones could barely call. Like every phone call had the likelihood of dropping, 10, 20%. It was just a terrible phone. But it was this machine that connected you to the internet. So it was worse, but it had that specific need that was there. Now, what I'm showing here is Cygnus. I could have used a CubeSat. You're going to talk about CubeSats later. Cygnus is a small spacecraft, a constellation, 8 spacecraft that's currently in flight, and it's looking at hurricanes and cyclones. The technologies that are being used are technologies that are a lot worse, a lot cheaper than any of these other spacecraft I just showed you. But it's a mission that cost $180 million. You say, that's expensive. Okay. If I build one mission of the previous technology, which is a radar, that one mission cost of the order 800 million. One. This is 8 for 180. And so if you have 8, why is that important? Well, we spread it out. So if you have a hurricane and you have the one mission, it takes between 3 and 4 days to come right over the hurricane again, over the center, and measure its intensity, which is a really important predictor. Here, it takes 4 hours, which is the important change, the important difference. So it is worse than was done. Actually, it uses GPS reflected off the surface, GPS signals reflected off the water surface instead of your own radar that you bring down. It can't do 100% of what the radar can do, but it can do most. And so basically, this is a disruptive technology because of that reason. It has the potential to really displace the standard technology because it's so much cheaper and so much more focused. So the point is, when you build an innovation program, whether it's in Switzerland or at NASA, you have to figure out where you're at, in which part you're at. These are the big ones, but you can't have many. I mean, at any one point in any organization, there's just a few of those. These are very narrow, very expensive. And these are the ones that if you can make them happen, they will change your life, just like these, but they do it in a very nasty way, in a way that the industry that's there, to a certain extent, has to shrink. And so you have to really analyze that and figure out where you're at and manage it. This is really hard to manage on the inside of NASA, for example. Actually, it was invented in universities and the National Science Foundation. NASA could not do it because it's really hard to, at the same time, do the best product of everything and then all of a sudden, a bad product, as people would say, even though it's really targeted and exactly the right thing to do. All right. So that's how I'm looking at technology. That's how we're managing technologies in each one of those buckets. I wanted to quickly talk about that. Does that make sense? That's the first task that I was supposed to, don't worry. The first task I was supposed to address. And what I'm going to do now is basically talk about any one of those stories. I could take one mission and talk about all of these aspects. What I'm going to do now is talk about the elements that it takes to make one of those miracles happen, one of those innovations, bring it to life, or come up with a fundamental science topic that really is transformative. They're really similar because they start with imagining the future in a way that's almost unreasonable. Good fundamental science or a good company, the first time you think about it, it sounds crazy a little bit because it's out there in the future. You grab the future, the why behind the research you focus on before you have any real way to get to it. The Voyager missions were missions that started at the center of the universe, of the solar system, of course, at the Earth, and wanted to explore 2 planets. What they realized is during that time period in the early 70s is that the 4 planets, the 4 giants, Jupiter, Saturn, Uranus, and Neptune, were lined up in a way that if we actually could hit that window, we could do all 4 at once. So we could look at all these 4 planets in one sweep. The time was short, it was really hard, and frankly, what we learned from Pioneer is that Jupiter had a horrible space environment. The radiation environment was a lot worse than even close by of the sun because of the radiation belts of Jupiter. And what the team did is they came together and basically pushed towards developing not just 1 mission, but 2, because they thought one of them will die. And they, over time, changed the name. It was actually the Jupiter-Saturn mission. And they changed the name to Voyager to open up the door to go beyond those 2. And as they say, the rest is history. Voyager has been in flight for close to 40 years. In fact, this year we're going to do an anniversary, a celebration of 40 years of exploration in a way that's rarely ever matched by any mission. For a long time, everything that we had in our books, in our school books about these outer planets were images from these missions. We now have Galileo, we have Cassini, but for Uranus and Neptune, besides some Hubble Space Telescope images and some ground-based images, that's what we know. Everything we know are from these missions. The reason there's a bubble here is all about the fact that actually just 2 years ago or 3 years ago, Voyager crossed that boundary region of the sphere of influence of the sun into the sphere of influence of the galaxy. And so that heliopause, that transition was crossed kind of to everybody's surprise after a cruise of a decade or so of very little news. So we're out there in the galactic environment for the first time ever with a mission that really was supposed to go for just explore just 2 planets. The point here that I'm trying to make, it's like in sports. My cousin is here who knows a lot about sports. Kind of the way you build a winning team is first you believe you're a winning team, then you win. It's not the other way around. You see yourself as a winner. You see yourself at the end. You see the why of where you're going. You believe in it. You embrace it before you build the path there. And that's absolutely, it's a really courageous, a really hard thing to do. Because during that time, many of the people will ridicule you. Many of the people will come up with all the reasons why you cannot be successful. And they're right. There are many reasons why you cannot be successful. But it's absolutely crucial to do that. Embrace that future, embrace that why, embrace that goal, an ambitious goal, and then go execute. That's, to me, what Voyager is all about. That's story number one. I want to talk about the Parker Solar Probe. Parker Solar Probe is the first mission to really plunge into the solar atmosphere, the corona. It goes to 10 solar radii, and basically will make measurements of the processes that heat this atmosphere, very likely the same processes that heat any other stellar atmosphere. As best we know from our observations, the similar kind of impacts, the similar kind of emissions that we see at the sun are elsewhere. See, the sun is really our Rosetta Stones for every star. Not every star is the same, of course, but we start at the sun. We look at gravity, look at the composition, we look at the many impacts. And so we're really trying to understand that interaction. Now, what I'm going to talk about here is the innovative key solution for the Parker Solar Probe. By the way, the first mission we ever named after a living person. Gene Parker is an incredible person who, when I counted the last time, there were 15 missions in our portfolio that did work that he predicted. And so he's just an incredible guy. The fact that he doesn't have a Nobel Prize says something about the Nobel Committee, not about him. But basically, here is the Parker Solar Probe. Now, what I want to talk about is constraints. Constraint is a limit to innovation. You basically say, here are all the solutions, but only these solutions matter. So we basically, for 30 years, we had solar probe missions that we wanted to do. And the solar probe mission that everybody talked about was one that went to Jupiter, turned around, and it came in at 4 solar radii, 4.5 solar radii. Really good reasons from that. Everybody defended it. The problem was, it was a mission that's between $3 to $5 billion, and the thing got so hot that we actually could not guarantee that it would come out the other end and actually get the data down. So we were fiddling around for 20, 30 years with this until a person currently in the job that I'm currently in previously basically said, hey, develop a mission that you can do for $1 billion. And what happened, of course, is basically there's a constraint. It's harder to develop it, but what this did, it took the status quo off the table. The crazy mission that we couldn't do, it was no longer an option. Nobody could do it for $1 billion. Done. We need a new idea. See, constraints are your friends. They're not your enemy when you innovate, because they help you come up with new ideas. They can't help you come up with different type of ideas. And what happened here is a mission was designed that goes out from Earth, goes by Venus, and basically uses Venus to pump down the periapsis, the close side of the ellipse, closer and closer to the sun until it's at that closest level. That's what I want to talk about here. So kind of the innovative solution is that one key insight, and I just wanted, there's multiple in each one of the missions that I could talk about. There's multiple ways to do this and multiple way of getting that key enabler. Here, I would argue, it's the constraint. And so often I could talk to you about other missions. It's again, the constraint that helped us come up with a solution. So innovation is not the more open, the better. Constraints are your friend when you're an innovator. The same is true with fundamental research, by the way. If you have constraints, it's a lot faster, often cheaper, and more focused to actually get the answers that you want. That's the story I want to tell here. I want to talk about Cassini now. Cassini is really an incredible mission. I'll tell you, since I'm at NASA, of the top 20 stories that we had by size, the biggest one was the one, where are you? You were responsible for, in part, which is the TRAPPIST-1 story. The first month, we had 3.5 billion people read that story. Billion, yeah. Cassini had, okay, out of the top 20 story, I just told you the top is TRAPPIST, 17 were from science, and out of the 17, 6 were from Cassini. So it's an incredible newsmaker. It's absolutely incredible what Cassini has done. And what I want to talk about here is the importance of a team. First of all, I want to say, if you have an idea and you're the only one who works on that idea, it's probably not a big one. The ideas that are worth working on are ideas that take a team. I want to talk about diversity. It's so often people talk about diversity in the context of kind of social justice. I think of diversity in the context of innovation. I'm a really impatient person. I'm a person, when I get insecure, I become loud. I always hire a person next to me who is an introvert who holds me back. Because together we're a better team. It's somebody who's really detail focused, not sometimes somebody who looks at the problem top down, somebody who looks at the problem bottoms up. And so teams are absolutely critical. Diverse teams that come together. That's, by the way, why Switzerland is so innovative, because there's so many different people coming together, 3 languages, 4 actually, languages, and people from many different backgrounds coming together, solving the problems. In Cassini, we have a team here. Of course, you already said that Cassini is ending in September. We're tossing it into the planet. We're now on an orbit, 22 orbits on the inside of the rings. And in September, we're plunging it in. The reason we do that, by the way, is we don't want to contaminate any one of the moons that we think could harbor life. So we want to go, do research and find our own bacteria there in decades to come. We want to drop it into the planet so we know it's gone. So, but in there were 3 space agencies: NASA, the European Space Agency, the Italian Space Agency. 270 researchers were core to the mission out of tens of countries that worked there. It was a team that, frankly, 17 countries to be exactly. It was a team that almost created the impossible. And they were so good because they came together as such, as a team with individuals with different opinions. Any one of these ideas requires such teams. If there's too many of just you, whether it's your startup, whether it's your research group, very likely it's not the best research group there is. It's not the best startup. You want teams with different viewpoints coming together, working on one goal, the one we designed, on that one solution that really makes it happen. All right. I want to talk about challenges now, and that's the Hubble story. The way we talked about Hubble, of course, is one way I could talk about it. It's the most successful mission we've ever done. End of story. Okay, the way I would measure it is by number of publications. As of this year, we had close to 15,000 publications. In Hubble, between 1 or 2 Nobel Prizes, depending on how you count. It also basically has still 1,000 publications per year, which none of the other missions can match. It's absolutely incredible what Hubble did. But Hubble started with a horrendously bad start. It's a telescope that has 2.4 meter primary mirror, and it was sold as the telescope to look into deep space. It was launched, and what happened after it was launched is it was not in focus. We could talk about the reason for that. It actually has everything to do with technical skills. Another reason why Switzerland can be so good at this. The technical skills that people bring to the table, that they do apprenticeships, that go to technical schools, is absolutely essential. It takes, to build an instrument, 1 or 2 of me, a PhD, and it takes 10 or so of the technical people. So the technical problem was what got us this. But the point is, it became a triumph of the collaboration of robotic exploration and human exploration. Of course, Claude Nicollet and 2 spacewalks was kind of encountering Hubble, one of them kind of moving Hubble around out of the shuttle bay. And basically what it reminds us of is that no matter what we do, every one of those missions has real challenges, or you could say mistakes. You could even say failures. If you're not willing to have a likelihood of some failures, you will never do big things. You have to not be perfect. You cannot be perfect if you're doing big things. That's what Hubble reminds us of. The question is how you deal with those failures. That's the difference between a winner and a loser. It's not whether or not you have mistakes or failures. We all do. For every mission, for every space instrument I ever built, there are 5 that I lost. And I was pretty successful. Most people, that ratio is even worse. Some of the best people have worse ratios. The point is, you have to fail to do big things. You have to have challenges, and the question is how you get through it. That's the Hubble story. I want to talk about Messenger, and it's one of those missions that I've been personally involved. There's actually on this spacecraft, which launched in 2004, got into orbit in 2011, and crashed into a planet in 2015. That spacecraft for me started in 1997. I wrote a publication that basically says how we could build a new type of sensor, kind of a fisheye lens for particles that then was put on this payload. And from 97, I just had done my PhD kind of 1-2 years later. From 97 all the way to 2015 is what it took to get really the first up and close look of in orbit look of planet Mercury, a look that will be by far improved once Pepe Colombo gets there with 2 spacecraft, the kind of stuff that you want to do to really understand the system as a whole. What I want to talk about here is that no matter how good a story sounds after it's told, patience is absolutely needed. It's not going as fast as you would think. Even if you're super successful, it takes patience. I want to talk about patience both ways. Sometimes not having too much patience is a strength. Kind of around the government, sometimes around academia, I believe we have too much patience. You know, kind of every once in a while, it's important to basically say, look, so patience, like, okay, here's the deadline, and we're going to move. So we only have 89% of all information. We're going to move. We're not going to wait till we have 100% of the invitation, all information. So the point is, patience, in most cases, is a really important strength, but you can't have too much, certainly at the beginning. The bottom line is, though, for any big project of the type that we're talking about, it will take longer. I remember talking to the Google founder and asked him, how did it feel for you? Google is one of the fastest growing companies. It was incredible how much patience it took, he told me. It's like nothing happened. Nobody used our stuff. We sat on that solution, you know, that search algorithm, and we couldn't make it work. We didn't have the money. To him, it felt it took a lot of patience, and needless to say, to them to get to where they are, it took tremendous amount of time to get to have the influence. The same with basically other companies that you can talk to, but the same is true with researchers. It always takes longer. There's the human factor that we cannot beat. We only have that kind of speed of your brain, that kind of speed of our computers, and that kind of speed of orbital mechanics. We cannot beat that. Certainly with this kind of system. We had to go fly twice by Venus, 3 times by Mercury, once by Earth first, before we finally got to Earth. So you get the point. You have to grab the future before you even know what it is. Start believing in it, embracing the why, be understanding the why, because if you can't do that, you can't get a team. You have to sell that, get kind of a movement behind that. You have to come up with an innovative solution. Sometimes, you know, the most important thing of an innovative solution is a constraint. Because it takes the standard solution that is a dead end off the table. You always need teams. Diverse teams are better because more different ideas together make better choices. You will have to overcome challenges. Any hard problems will lead to challenges, perhaps even failures on the way to success. There's no way to success without any rocks. And you just have to remember that. And no matter how fast you try, no matter how hard how much money you raise in your company, it will take patience for you to get where you want to be. That's what I wanted to say. Thanks so much.
Thank you. Stay with me. Stay with me.
Okay.
It sounds so logical. Or don't you agree? But how many failures, how many victories, how many sad experiences did you have to experience before you had this clear system of these 5 points? Or how long took it for you to achieve this 5-point system?
Many. I'll tell you, so I'm making mission selections now. I make a point to call every winner and every loser personally. And the reason I call every loser, I call them up and basically say, look, I'm going to give you bad news. I'm giving you the bad news because I know exactly how it feels. I have more bad news stories that I got than you ever will, I hope. And I'll tell you, you'll overcome. It's just fine. For me, many of the failures were more important for my future, it turned out, than the successes. If I had all successes, I would not have the job right now. So I had, for a while, I had 7 excellent proposals. Those are the top class of the proposals they could be selected on that were not selected. For this one, I did not get on, and I should have. So this one, I got kicked off Messenger. For 2-3 weeks, my instrument was kicked off for political reasons. It had nothing to do with me, but I was kicked off, and we got it back on. So basically, these kind of things are absolutely, and they're agonizing. They have to hurt. See, if it's not hurting, you're not caring. You have to care. You have to have your heart in it, right? Kind of, it's not a head type of thing. I mean, you cannot be successful if you're a machine.
But I heard also you say you have to give your heart for the project, but you said, I realized it has nothing to do with me. Is this a gift too, to separate from me personally and me, the project? And sometimes it's the circumstances, it's the world going around and not you failing. Exactly
right. So I really do believe what I said, under the challenges. Whether or not you lie on your back from time to time, it's not really a good question. You will. But the question is how fast you get up. And so once I think it's important. Every once in a while, you have to go out, have a few drinks, right? And kind of dump it on the table. Then you go home, sleep. Then you say, okay, what's the path out? And so for me, in some of these things, it took me longer. But, in this one, it basically took me, I recognized it was happening. Probably it took 2 to 3 weeks, but, I couldn't do it by myself, by the way. But I knew whom to call to get enough pressure on NASA to get me back on, so kind of which congressman needed to call in, which, and so forth. And so you can't do that when you're pouting in your room, right? You have to focus again, go back again through that cycle. You have to focus again on the solution and do it. So again, the shorter the time is at which you're kind of self-pitying yourself, the faster you get to your goal. That's what I learned. And you learn it with, I have a lot of scars on my back.
Okay.
And so, but that's what innovators have. It's not, if you're not an innovator, if you want to do kind of just little steps all the time, you don't have that, but you never do amazing things, most likely.
A famous Berner Oberländer, Adolf Ogi, said once, the resilience, the time, how fast you get on your feet again, you can train this with sports. Do you agree?
Oh, absolutely. I think sports is one of the most important things for people to do when they're young, for a simple reason. You have to learn how to lose. It took me forever. For whatever reason, we can go into stories. I was not doing sports until I was 15 or so. I could not lose. And so basically every time I lost, like first of all, I started fouling people. Like I became a jerk because I started losing. It's like, that's not okay. You have to learn how to lose. It's not because you like losing, because you have to bounce back. So I think, I put all my kids, kind of my point to them is, I will not force you into any sport. You will do one. Because most of the time you lose. If you're a runner, you almost always lose. If you're playing a team sport, you lose 50% if you're pretty good, right? But or just a little bit more. So I really believe that's right. Especially now, I can't speak to the Swiss system, but kind of with great inflation and everything, everybody is everybody's in the top 5%. Kind of when you look at recommendation letters and kind of in that kind of environment, there's not enough of that kind of rocketizing that you need to really make it through these things. And so I think sports is really good.
A good recommendation. So are there questions, I would say, in the personal sphere of our guest, the science we would have later on when we have the other participants and at the round table? Some questions can... Why is that?
These days we have to prove in the proposal more or less that it's possible. And yeah, how does that fit to each other?
So you're asking, the proposals you say today are really different than this, and how do you It seems like an apparent contradiction to what I just said, right? So I'll tell you what I think a proposal is. A proposal is telling a story of the future that everybody can be excited about. It's a story. A proposal, there's technical data, but I've been on many of the panels. It's a story. When a proposal comes to me, when everything is said and done for a given NASA mission, you know, ultimately I make the decision. I imagine what will the future be if that mission is flying. What are the papers that I will see in Science and Nature? What are in Astrophysical Journal, you know, or whatever the journals are. So it's that vision of the future. What we're trying to do on PI class missions is we're trying to really, what we're going to do is give them principal investigator class mission. We give them a cost cap. So we really basically say, can you do it for fill in the blank, $180 million? Can you do it for $500 million? And so basically we look at the technical pieces there. I basically believe in the one miracle rule, which is I'm perfectly fine if one technology is not developed, but you can't have 3 or 4 miracles. I actually know that. So we did analysis of all missions and looked how the cost relates to this, how many new technologies we need to do. And so one miracle in that kind of mission, yeah, it's not 50 miracles or 10 like James Webb. Remember, James Webb is $8 billion. The most expensive mission, they started with 1. That's what happens if you have 10 technologies. So not every mission is the same, but for the principal investigator class missions, the ones that require proposals, 1 is okay, but never forget, it's really about in the proposal, drawing out what the future is, really explaining it and making sure that everybody understands that it's worth taking that risk. Once you do that, the rest is really checking the boxes. It's hard to write these proposals. I've done many, but that's how I think about it. For directed missions, strategic missions, it's a different process. So there we take more risks in that respect, but you don't typically write a proposal for the spacecraft itself, perhaps just for the mission, for the instrument. So it's a little bit different there. But you're right. So see, not everything is equally risky. I didn't mean to imply that. Some of the time we really put things in a box and we make sure it fits in a box. Some of the time we're okay taking a few risks. This one is a 3 miracle story. And the way we manage to keep it in the box, it's actually within 20% or so from the first cost estimate. The reason we got it in the box is because so we actually had it basically ready to go. Good point, though.
One more question before we open the panel. Yes. No, wait until you got the microphone. It's not because we couldn't hear you, but it's because we would like to record.
Okay. Since personal questions were allowed, I was wondering if you have worries for the future, and if so, what are your biggest worries?
Oh, this makes him...
I don't know. I mean, it's so hard, right? Probably the biggest worries relate to my family. Do you see? I mean, as a father, are my kids going to be great? Is everything going well? For me, so it's that sphere. I spend more time worrying about that than other things. If I look at the science program, perhaps that's what you're asking. I don't know. I mean, for me, a worry that I have, just interesting things happening in the world, right? For a long time, it looked like the whole world was evolving towards everybody becomes a democracy with a free market economy. And God, did we ever hit a wall, right? Basically everywhere on Earth, in many places, whether it's in Turkey, whether it's in Russia, whether it's in the UK, the US, in many places, there's important voices that basically say, hey, this is not working for us. There's people that are left behind in that. And I think that tension, we haven't figured out how to go from there to the next state. I don't think the kind of solution of this one is in the past. I think it's a macroscopic thing, and it fills me with worries just because I don't really understand what the solution is of it. But there's clearly a macroscopic picture that is there. The world got a lot richer, a lot better, a lot more less sick, relative to illnesses of the type that Dr. Tunner is working on. But at the same time, we're hitting some challenges. So it's that macroscopic piece that I think fills me with worries.
Give us your question.
What do you think about Elon Musk's ambitions? And we know that he started SpaceX with NASA's money, and but now is he a competitor? And what do you think about what he's saying?
So first of all, I know him well. He's a great guy. I'm so glad he's there because he stirs the pot. I think he made us, like, remember how I said that sometimes we're too patient? He's not too patient. He's probably not patient enough at times, I would say, but he creates that kind of diversity of opinion, kind of to look at. You know, so in many ways, yes, NASA, the first few billions of dollars that he got in SpaceX came from NASA. It's not raised from the economic sphere, but it created a company that really changed the whole launch market. With a pure US perspective, it was a launch market that was close to 20–30% US. The rest was foreign. It's back to 70–80% US because of SpaceX and other companies that are right behind them. I actually believe that the biggest companies are still developing. I think you should watch Jeff Bezos's company. I think it's a really amazing company. What's happening in the background is absolutely stunning. There's 2 small launch companies, one in New Zealand, one in the US. That's also coming. There's also European launch companies, but it's created an economy of a launch market that is cheaper. That is so good for us. I'm so glad it happened. Is he a competitor? No. There's many things we do. What we just did is I actually put the technical term is an RFI, a request for information. I put kind of a question for potential partnerships out from NASA that basically says, hey, if somebody's going to the moon, tell us. Because I don't want to build my own spacecraft. I just put my instrument in your trunk and fly there. So kind of my point is, I'm always focused on the most science per dollars. I don't need to own everything at all. Absolutely not. And so for me, it creates options. How we bring samples back from Mars is really different if Elon Musk is there. There's certain things I do no longer have to do that he can take over. For example, I may be able over time to buy communications by the yard. You know, by however many megabits of data down I pay him instead of building a whole spacecraft that just does communications. So I think it enhances options, and it is overall a good thing for all of space internationally because it basically drove the cost down.
So I said we have more questions afterwards. I suggest we break up now that wall and ask the other 3 participants to take their seats on the panel, and you got possibility to ask your question afterwards.
I'll take this off, right?
So, well, we open up now the discussion a little bit, and I will present you who is joining us. Well, I start with the one who might be the most well-known in this area. It's Nick Thomas. He is actually a professor for experimental physics here at the University of Bern, the leader of the Planetary Imaging Group, and he is the president of the Committee on Space Research at the Swiss Academy of Sciences. And I like to introduce each of these participants with one more or less personal question too, before we start to the hard science and hard business then. Nick Thomas, I've seen a video from, it's just a few years old now, but you with a painted face, like Ziggy Stardust from David Bowie, coming to the stage with a carbon dioxide fog and rock music. And is that the kind of it's about communication? Huh? Is that the kind of communication you think is a good way to reach people with that kind of showy element?
It's one of the things that we tend not to do regularly.
But sometimes
getting dressed up. And,
how often did you paint as Ziggy Stardust?
I think I've only done it twice.
Okay.
Once was only a prototype for that. I've never done it again. But it was just the reason for doing it in that particular forum was simply because over the years the presentations that we'd seen in this particular forum had been rather dry, and I just had a feeling, well, come on, let's do something a bit nuts for a change, and it seemed to work. I do want to say, however, that perhaps on a more serious note, that science communication and using space for science communication and to attract younger people into sciences is really an extremely important thing. Space has a huge visibility, and it's very, very attractive to the general public. It's very attractive to kids. We see, for example, we do a little questionnaire for the first year students about why did they choose to come to the University of Bern. And almost always space is the highest thing on the list, that they found the idea that the University of Bern is involved in space sciences extremely attractive. It's one of the reasons for coming here.
Okay.
In the end, they don't all end up in space. They go and do climate. A lot of them go into particle physics and into theory. But it attracts them into this area because it's a very visible science, and I think that's also something that is maybe not often appreciated, that it does have this cultural aspect behind it. And so I'd be prepared to get dressed up as Ziggy Stardust again, as long as I can guarantee that I'm going to get a larger number of students coming in the first semester.
Okay. We're looking forward to your next show then. But the attractivity of space research leads me to the next participant in the panel. It's Renato Crepon. He is the head of the Swiss Space Office at the State Secretary for Education, Research and Innovation. And there you're the chief science in space science in Switzerland. And we heard space is attractive. It attracts students, but you as a representative of the Eidgenossenschaft, why is it important to Switzerland?
So maybe first I need to correct, I'm not the chief scientist in Switzerland. I'm the head of the Swiss Space Office. And of course I represent the Confederation at the European Space Agency as head of delegation, which in a sense, we also discuss science missions, but not as, it's not our focus or not our only focus. So if I come to your question, space in Switzerland is much more broad than just sciences. I think it has become part of our daily lives, even if we sometimes don't realize it. I mean, we use navigation systems which are based on space infrastructure. We have meteorology, we have communication, and that's what we know from today. And in the future, what we see is coming is that we'll have ubiquitous communication all over the planet. We'll have big data from space. We were talking about the Cygnus missions earlier on, where we were talking about several days to get new information about our planet. Now we're getting into a situation where we almost get information immediately, thanks also to optical communication, thanks to data transmittal satellites and so on. So it's a very big part of our daily life. And at the Swiss Space Office, we basically see different areas. So we have space infrastructures, I just mentioned. We have part is access to space. How do we get to space? I mean, we talked about the American side. There is also the European side of it. We're working on Ariane 6 now with different actors in Switzerland also contributing. We have the exploration part where Switzerland through its engagement into the European Space Agency. So we don't have an agency such as NASA. Our agency is the European Space Agency. So 95% of our budget goes into the European Space Agency. And so there we develop also exploration programs, space science, earth science, and of course more the commercial parts when we talk about public-private partnerships, also similar as what NASA is doing. So this gives you a bit a view of what we do. But I would like to join also Nick's statement from before. I mean, we also see space as a very important part of the STEM movement, like to get youngsters motivated and inspired to join into the natural sciences field. I think it's a very, very important, and it's something which is very important and often not realized.
Mm-hmm.
Thank you.
Thank you. We'll be back with you afterwards later on in the discussion. I'd like to present you the third participant. It's Julian Harris. He is the co-founder of a company that changes in 2 weeks, or what? His name?
Changes the name, yes.
Changes the name.
In a few weeks.
In a few weeks, okay. This company was called Space Electronics, and it will be called Astrocast. It's a system of worldwide communication built up with 64 microsatellites flying around the world and enabling a machine-to-machine communication. And you are doing this as a private company. And I was close to asking you whether this is a business, coming back to Jeff Bezos and Elon Musk, but I prefer the next question on your, because we can answer this afterwards, whether it's a business. I prefer the next question. I've seen in your LinkedIn profile, I've seen that you present yourself as a rock star and electronic genius. So first, because I'm an aficionado of rock too, what kind of rock star are you?
Well,
we had Ziggy Stardust and now another rock star.
Well, it's true. I'm a singer in a rock band. I do some tours around the Alps and stuff. Yeah, I sing a bit of David Bowie as well. And yeah, this was from probably from the 70s. We do a lot of 70s kind of rock stuff. I didn't write the bit about being an electronics genius, but I'll take it.
But this is copy and paste from your LinkedIn from your LinkedIn profile.
Yeah, from the 70s, in the days of David Bowie and Queen, got a lot of links to.
And how long was your hair then?
Oh, I've had very long hair. It's not on my profile, no.
No.
Not in the 70s, but it was a downhill.
Okay, and you were a headbanger?
No.
No headbanger, okay.
No. A bit Bowie. But, you know, this was from time in the 70s when we were listening to this kind of music, Bowie, Queen, watching Star Wars, these kind of things, and dreaming about, strangely, when I was 7, I wanted to come and live in Switzerland. So I had to wait about 30 years before I did that. But yeah, I became a rock star. I wanted to build spaceships, as I called them at the time, and live in Switzerland when I was 8 years old. And I do.
And the guitar,
what I do.
You mentioned Queen, the guitarist of Queen, Brian May, has a PhD in astrophysics.
Yes. Just from upstairs, from where I built the cluster, an instrument for the cluster mission. He did his PhD in astronomy in 2 floors above us. Although I never met him.
So he was your idol on 2 fields.
Absolutely, yeah.
Okay.
Guitar, yeah.
Guitar
I
and
him as a guitarist and wanted to
science.
And science as well, yeah. So,
okay.
So I think the 2 things, rock star, rockets, you know, it all goes together, really.
Okay.
There's an awful lot of guitarists.
A rocket star.
At Aztec, there's a lot of guitarists.
And another guitarist, we're talking, I'm a guitar player too. Another guitarist is named Moon. Is that a coincidence?
Keith Moon. Keith Moon was a drummer.
He was the drummer. Sorry.
He was the best.
Okay.
The best of the best.
Let's get back to science and NASA. Thomas Zurbuchen, I was asked to ask you to give us a little transparency on the selection process of how NASA selects missions and how it evaluates proposals. Can you give us a little insight in this project, in this process, and then perhaps ask the three scientists how they experience the collaboration? But give us first your insight.
So the most important ingredient to proposals totally is actually a strategic view that I'm not responsible for. I'm not in charge of prioritizing science. The national academies in the US are in charge to giving kind of 10-year plans and kind of prioritize what the top science is on a 10-year time scale. Everything we do, we match to that. And I don't question it. It's really a relief for me, because if I'm like sitting there, walk into the office and basically I have to say, what's the most important science? Is it X-ray astrophysics? Is it exoplanets? Is it seeing in the deep universe? You know, just to speak on astrophysics, I could do a planetary. Is it going to Venus? Is it going back to the moon? You know, I could do all these things. If I had to do that, it would be very hard. So basically the first overlay is a strategic view that I get from the outside. And I'm really glad for that. And then I think we just talked about kind of in a PI class, kind of for smaller missions where people compete for the missions. There's really three elements that we're looking at. The first one is, what's the science that is promised? It's a really important part. So it's what I talked about. It's kind of the overall, if everything went well, all your dreams worked out like you wished as a proposing team, what do we know in 10, 15 years that we don't know today? That's really what that first part is about. The second one is, how are the instruments working towards giving that new data? That's the second part. And so basically what we have there in each one of those parts, by the way, we have a series of experts coming in and basically reading the proposal in detail. We put them on the contract. They work for close to a half a year in round numbers on just getting the information together. The third part is one that's looking at management, kind of schedule and cost, that basically says, well, compared to missions that look just like these, are the numbers that we're getting reasonable, achievable, to basically get to that goal? And so basically we have those three elements. Now, what's then coming from that, there's a big process, and what's coming to me as a decision official is basically ranking of each one of those missions in these categories. It's up to me to figure out how much risk I want to take. The process itself does not say how much risk I want to take. Basically says, look, this is more risky, this is less risky. And then that's translated into categorization. It's category 1, which is clean, it's, you know, whatever. Doesn't have, perhaps it's not the most exciting, but, you know, and category 2 and so forth. And kind of what I will do, together with our team, of course, I'm never acting in isolation. That's not smart. I'm just not smart enough for that, right? And so I work with the team, and we basically struggle through basically making selections. And so basically I will eventually basically pick out of the 2 or 3, I will pick, you know, the one that will fly.
So do I have to understand that there's just one person and it's you who takes at the end the final decision?
Absolutely.
Okay.
I basically, at the end, I basically said, this is what we're going to do.
Okay.
But as I said, I'm not smart if I'm not listening to others. So basically the way you should imagine it, I'm around the table, and it depends a little bit how it goes. It may be in many of the selections, especially the large ones, the team has 1 hour to convince me. It's a really hard hour for them. I sit at the top of the table and they come in, and it's basically, if they win, it changes their life,
of course,
right? And so basically I feel bad for them, but it's high pressure. So they come in there, and you know, at the end, basically, so if it's a planetary mission, the Earth Science Director is also there. The Heliophysics Director is also there. My budget person is also there. And often we struggle, we basically say, like, to the Earth scientist, does this look compelling, this planetary science? Because it can't just be a kind of tunnel vision type of mission. And it's like, if the only people who understand it is one expert field, and I'm like, I'm not sure whether it's the mission we should do as a selection. But at the end, it's my signatures. The way NASA works, at the end, the decision process is one single person. I mean, it's basically one person signs. Also, when we launch, I sign. We're ready to launch. And so that means I'm always on an ejection seat, so to say. I could get it wrong. And, but, so kind of, I'm trying to be rather unemotional about it. So I'm not going after, so I'm basically trying to look, I believe in matrices, look at the various aspects and do it. But at the end, it's one decision, yes.
Professor Thomas, have you had experiences with projects proposing to NASA?
Yes, many, actually.
How was your experience during that selection process?
Actually, extremely positive. The way in which the process operates from where I sit normally is that I get typically I would be invited as a scientist to participate in a program, in a proposal. So, for example, I've actually only about 3 or 4 days ago, been invited to participate in a project that we'll submit to a future program that will come onto Thomas's desk. And then I'm not going to tell you. We get, and then you write your proposal to an announcement, what's called an announcement of opportunity. And this is actually a really fun thing to do, because I like very much the way in which, in particular on the American side, normally it's a collaboration between a number of scientists, and you put a lot of effort into writing these proposals because they're so important. They can, as he says, they can change lives. And you put a huge amount of effort into structuring your proposal, into trying to answer the call in the best way that you can. Trying on the one hand to be realistic, but on the other hand in generating a sort of a dream. What can you really do something and really make a large step forward in the particular science. And this work goes on. You're often given warning that something is going to happen, and then you have a certain amount of time to answer the final call. And then it goes through an evaluation process, and you know that it goes through this evaluation process a long time before it comes onto his desk in the end. And that evaluation process is thorough. I also have to say, of course, that I have experiences with the European Space Agency. And the European Space Agency does very much the same thing. There's a very thorough evaluation process. You don't get onto these missions just by flicking a coin and saying, hey, yeah, I'm on, right? It doesn't work that way. It's a really thorough evaluation. And if you end up being selected, you know that you have, on the one hand, you've written a damn good proposal because there's serious competition. It's really no joke. And on the other hand, you've also got a certain responsibility then. You're being given, we in Switzerland would not get money from NASA. We have to go to the Swiss Space Office. So here, I'm enclosed here by the money holders here, which is not necessarily a bad thing. But you are under a responsibility then to deliver what you proposed. And that's also something that you have to take seriously.
But let us compare the two money holders. And NASA and ESA do work differently, because ESA kind of gives you the opportunity to contribute an experiment or an instrument, and NASA is the partner to develop that technology, that experiment.
Not always.
Not always.
Not always. I mean, there are different means of proposing experiments to a mission. For example, in the one case, if NASA issues a call, an announcement of opportunity, one can propose as a European to develop an instrument to a NASA mission, but then one has to speak to the Swiss Space Office and say, listen, I'm intending to propose to a NASA mission. Are you able to fund this? And I have to have a letter from the Swiss Space Office saying, yes, we would be prepared to fund this if it was selected. This is one mode. Another mode might be NASA issues a call, an American institute responds to that call but says, hey, Nick, would you be prepared to provide a piece of my experiment? And then again, I have to go and talk to the Swiss Space Office and say, would you be able to fund this little tiny piece of this experiment? It's not going to cost very much money. I'm sure you've got it in your pocket. Start. Okay. We can do that. All right.
Mm-hmm.
And then then there's the other case might be where you would have a European Space Agency mission. And there, I don't have to talk to him at all. You know, I just have to talk to my friend here, and just say, "Have you got a lot of money to pay for a European Space Agency instrument?" So there are many different means, depending upon which is the funding organization and which is the consortium, how the consortium is built, and that's often a discussion process that goes on in an initial phase before the proposal is submitted.
How important, Thomas Zurbuchen, are the relations from NASA to ESA? We heard for the researcher, both ways are important, and it's kind of a mixture of relations. How important is for you, NASA?
So for me personally, right, I mean, I'm a guy who worked on SOHO, so European Space Agency mission with NASA participation, Ulysses, which is, a similar kind of collaboration, and then worked on missions, ACE, for example, a NASA mission with European, Swiss contributions and so forth. If you stand back and look at the portfolio that we have, close to 2/3 of all spacecraft have international collaborations, and the most important collaborator just by amount and type of collaborations is European Space Agency. So it's not unusual that I speak monthly or sometimes more. Like 2 days ago, I spoke to my colleague at the European Space Agency. So we're constantly in contact just because we want to make sure that we work together. We have slightly different rhythms, different decision processes, even though we have similar kind of analysis, at the end, I make a decision, and so basically I need to make sure that we're not going too fast at times. We have examples where we went too fast. Our Europa mission, kind of the way it happened, this was mostly because there was so much congressional pressure. We went so fast, Europeans could not respond to it. And kind of in retrospect, you basically say, well, was that good or bad? Well, it's good because we have a mission that's flying, but did we really get the best instruments? Did we get the best teams? I don't know. Kind of history would say typically not, because of the fact that we moved so fast, and so basically we have similar, because we try to really stay in touch with each other. It's absolutely critical for us, and we believe that kind of at the government level, so it's an important part of the diplomacy of the United States, kind of a friendly interaction. We want to work with as many as we can. I mean, we're really encouraging that with Japan, with other partners, Russia. We've worked often with Russia, even if the politicals were kind of shouting at each other. We worked really well with each other, and we're proud of that.
And on a scale, how important is Switzerland? We believe we are important, and we heard it from the State Secretary of that we are important for space research. But how important are we, or Switzerland, to NASA? And don't be too polite, be realistic.
No, I mean, I can give you the numbers, right? I have 104 missions. 10 of them have Swiss contributions.
Okay.
So it's kind of a 10% effect. To 0.3
of smallness,
so it's, you look at Switzerland. I think what Switzerland is doing well and has done well is to really focus on niches, so to say, that they can just dominate and look at the kind of stuff that Peter Wirtz is doing and his colleagues relative to particle calibration systems. I mean, it's the best in the world. It's like nowhere on earth you can do better. Look at the kind of work, some of the modeling, some of the work that you're doing with the instruments that you're building. It's like, on earth, there's probably 2 or 3 places that could do some of the instruments, and kind of in Europe, you're clearly the leader, right? And so basically, so the same is true with some of the climate sciences, like you look at what Zurich is doing, the ETH, you look at what Lausanne is doing. So there's some really important niches. You know, almost every rocket that we're launching on has a Swiss tip. You know, the fairing, as we call it. You know, from Ruach. I mean, it's like the technologies there everywhere. On our Mars rovers, some of the motors are from Switzerland, right? And you know, what Switzerland, I think that the trick is not to cover the space everywhere. If you're kind of a country of the size of Switzerland, it's to basically find out what the niches are in which we can dominate. And so that's why you're then really relevant, even though, you know, the overall, just kind of, if you add up all the millions of dollars, you may not, you know, be at the same level as France, for example, or whatever, pick another country, right? But you can still have, and despite that, or because remember, it's constraints. If you use your constraints well, you will create leadership. And I think Switzerland in many ways have done that.
Talking to some researchers, to some space researchers for my preparation for this panel, I heard the rumors, or I heard the opinion that NASA's reliability as a partner is sinking, because sometimes they're in and then they're out in a project, and then again they come and say, oh, it has to go very fast now, let's go. And are you aware that your partners are feeling kind of sinking reliability?
Sure. I mean, it's, you know, so basically what that says, look, I mean, our appropriation is on a yearly basis. It's different than Europe. You know, like, again, we're different partners. We have different strengths. We have different weaknesses. So I can make faster decisions, but my decisions may be overturned. Like, you know, a given dollar that I'm spending has been agreed upon by the administration that's there, the House and the Senate, right? And so basically any one of those three now can take that off. By the way, the administration is not just one person, not just the president. We have the Office of Management and Budget that has really a lot to say. So basically I meet with them on a regular basis, right? So basically for me, it's my job to kind of see things coming, understand where the constraints are. And if you misjudge, then you make these sudden turns. Now, overall, science funding has actually been really stable. So if you look at the historic science funding over the last 20 years, it's remarkably stable. It's within, you know, 5% or something like that. It's just that certain directives, you know, see, trust is really hard, whether it's interpersonal or whether it's between companies. It's first of all, you can't turn on the trust switch, right? You have to earn trust. And what's really the bad part is losing trust is a switch. And so basically, if you look at the kind of statements that are underlying these things, it relates to the Mars mission. It relates to the gravitational waves mission, in which we did things. There's certain lessons from each one of them, and you know, that was before I was there. But the bottom line is that happens every once in a while, and it's part of the system. You know, we have. I mean, I don't know. I mean, I could apologize for it, or all I can do is basically what I'm doing is tell my European counterpart everything. So I over-communicate. Look, I see this coming. How would you react if it happened? Right. So I don't surprise them, both in the positive and the negative.
Okay,
yeah, I'd just like to say a little bit about that as well, because of you alluded to it already about the Mars situation, because this is one of the things that I experienced, in that originally the European ExoMars Trace Gas Orbiter was a joint ESA-NASA mission, and we were involved with a camera system which was being led by the University of Arizona, and we were contributing only a relatively small part of that instrument to that mission. And then through, as I understood it, no fault of NASA headquarters, then NASA was forced to pull out. However, this caused a certain amount of trouble, and with the help of the Swiss Space Office and with ESA, we managed to get this thing back on track, and that became the Cassis camera system that is currently flying on TGO and will enter its prime mission in April next year. But one thing that I want to say about the issue of trust here is that the teams in Switzerland and in Arizona have been continuing to work together in support of rebuilding the elements of trust, or maintaining, I would say, much better, the elements of trust. And in fact, the University of Arizona has been helping us enormously in supporting our operational software developments and so on. And so we're maintaining these links at research level, at scientific researcher level, and looking to maintain our networks, irrespective of these decisions that are taken at higher levels, even above the ones that Thomas occupies right now. So we do our best to work around these. It doesn't help bearing grudges about these things. You have to work around it, and in maintaining your cooperation and maintaining your network in the best way that you possibly can. And we try to do that.
Mm. Mm-hmm. Are there questions from the audience concerning cooperation, application, trust, reliability? Please wait until you got the microphone, and then we go to a more scientific debate.
Yes, good morning, Odagiano Rouge. In the last couple of years, we have seen a steady growing influence of China in space. Just for example, they might bring back samples from the moon in the next year or so. I think that has not been done in the last 40 years. And now a little bit provocative, maybe it is at the expense of the US influence in space. So I wanted to know how is Switzerland and with its partner in Europe and in NASA, how it's reacting, what's the position of Switzerland? Is it changing, in this new context?
Who?
So, I mean, the advantage we have, we're somewhere in between, and Europe has been very good in building these kind of bridges, in Switzerland also. I mean, I think, European Space Agency is very active in that direction. So there are different talks which take place on the American side, also on the Chinese side, on also what happened to the International Space Station after it is decommissioned, maybe in 2024, 2028, we will see. Is there a new program coming? It's not just Europe which will be deciding, but can we bring different partners on board? Maybe China also. Of course, they have their own ambition. On a more national scale, we have certain groups which are working. We have, I think, Nicolas Produit, who is sitting in the audience. He has an experiment, which is on the Chinese space station, if I'm not mistaken. So there is collaboration also on a more smaller scale. But again, Switzerland is and I think maybe that's one of the strong parts in Switzerland is we don't dictate top down what needs to be done, but we have the actors which come bottom up and decide we want to work together with the Chinese, or we want to work together with the United States, and this makes somehow the force of the whole system, is that we're not trying to push a certain direction. It is really up to the researchers to decide where they want to develop instruments and with whom they want to partner.
Please.
My question is probably mostly to Mr. Thomas Zurbuchen. After half a year with the new administration in the USA, do you feel somehow in which direction NASA is probably going to develop? Is it more isolation cooperation? Is space at all still important for the new president or not?
Let me start with the final question. I mean, there's never been a president who has spent more time on space than this one in the first 6 months. We actually had, I think, 7 events where he specifically talked about space. There was one weekly address was entirely focused on space science. That has never happened, not with the previous president or before. Overall, kind of the most important thing, there's 2 ways of answering the other questions. The first one is to listen of what people say kind of in the sphere. And the other one, frankly, I don't really care what people say. I want to look at the money. Show me the money. At the end, am I being supported? And so basically, if you look at that, there's 2 budgets one budget that came is basically in going through the cycle, one that we're developing right now. And the budget that we got was very positive. So kind of overall, actually, if you look at the agencies, we fared extraordinarily well. It was almost, so we wanted to, we have some issues that we have to address, but the point is we feel a lot of support. By the way, that is not a huge surprise in the following sense. NASA, of all the agencies, is one of the most bipartisan. So kind of, that's why I said that the money has been such steady state, because many agencies are very different. Take the Environmental Protection Agency. It goes up with the administration and down with the administration for years. It always makes news, but the point is it just goes right because it has kind of one party embraces it, the other one less so. And so the same is true with other agencies. NASA is not like that. So has it stabilized? That's the first question that you asked. And the answer is, of course, no, in the sense that we don't have an administrator yet, right? So there's certain decisions we cannot take today, kind of big change decisions we can't take without a new administrator. So kind of any reasonable person in the White House would say, look, wait until you have an administrator. So the administrator can take credit for a new decision that may be big or have an international impact. And so we're surfing, like you could get beat up by waves or you could surf. So I make the decision to surf, stand on a wave and take advantage of opportunities that offer up and move. Science overall has done really well so far. And it's not just because of the administration. It's also we have tremendous support on Capitol Hill, both in the Senate and the House, just like I said. The two chambers are a little bit different in their emphasis, but they've really come together and have supported science. So I'm optimistic where we are, but no, it hasn't settled yet. It's kind of a fluid situation, and you have to learn how to work in that kind of situation, right? And do the best for the community, which is the only reason I'm there, right? It's not a job to somewhere else. It's the job to really do the best we can.
The lady was asking before, yeah.
Yeah, I'm surfing a little bit as well. I'm doing economic promotion on the continental level. So we are funded from Geneva to Bern for Western Switzerland, half of Switzerland. Our job is to bring companies to Switzerland. So we're the first contact for foreign companies, and I have colleagues all over the world. So we work all together with the different ministries, the continental ministries. My question is, I have like two questions. The first one is, we were talking about niches, because I really personally as well believe that space industry is a big topic next to life science and others. What are these niches we can put forward? Because sometimes we are not aware about what's going on. And then my other question, linked to my first one, is about big data. You were not talking about this challenge, but when I talk about to people in ecology, for instance, in life science, they always say that big data is their biggest issue right now. And I think we can actually couple it to the space industry. I'm sure that these are high topics. How can we position Switzerland, and I'm not talking only about Western Switzerland, globally, how can we position ourselves for these issues we have right now and the upcoming issues?
Is it for...
Yeah, I think it's more
it's yours, huh?
on our side. So, well, we ask ourselves very similar questions at the Swiss Space Office. So, of course, we have certain developed niches which are very visible in Switzerland. We talked about the fairings. That's a very well-known product we have in Switzerland. We have also atomic clocks. Sometimes the niches are quite different. Where we see somehow an agglomeration starting in Switzerland is on the more kind of telecom payload side, where we see on one hand we have optical communication, two strong players in Switzerland. We have also on other sides we have certain operators coming into Switzerland. Viasat, we have small startups like LZ Astrocast. So there is kind of a movement around that, and of course then we have the science part, which is very strong. maybe less interesting from an economic perspective. From startups, but as we have seen, we can bring in new technology developments through science into the industrial change. So this is also a very interesting part.
So coming to the startup finally for Astrocast, what would be for you the surrounding that you need to build your great idea and to make it fly?
Well, we as Thomas was talking about constraints, if you think we were 4 or 5 guys in a cafe who were involved in the space business in Switzerland, wondering how to build satellites and make business from satellites. So as we're wondering who's going to pay for the coffee, we realized we probably can't build a big satellite, right? And operate a big satellite, because we know enough about the space industry to know that that's completely unfeasible for us. So the constraints were cheap. We need skilled people, but we need to do it cheaply, and then maybe we can move into the satellite market. So one of us, me, worked for more ESA missions, scientific missions. 2 guys worked on CubeSats. So we put these together and realized we tried to realize how could we make a business with CubeSats, because that's our constraint. So we then realized that a CubeSat is generally something that's made commercially, commercial materials, commercial components, lasts for about 3 months in space. You can't really do business with a satellite that lasts for 3 months. So we tried to bring these together. These expertise from the EPFL, for example, in CubeSat technology, the expertise that we have scientifically in Switzerland from the scientific instruments that we produce, like Nick does, and this kind of high reliability technology, we put them together and see where we can fit into the market and find a niche in the market. And we think when you ask if we can do business with CubeSats, let's say yes, we hope we can, because we're a startup company.
Yep.
And it's very, very difficult to be a startup company in the space business. But this is the way that we think using these nanosats with the support from the Swiss Space Office, etc., that we can do business with these, with what we have in Switzerland already. It's purely Swiss, based on EPFL and the scientific side of Switzerland as well.
But you have heard the question, what can the administration or the state do to attract companies in that field, space industry? You have a wish. What would be what you need?
Money.
Well, apart from money,
okay, we're a bunch of technical satellite guys, really, but we've moved into the big heady world of business, which to begin with we didn't really know much about. We need to address customers. We need to address marketing. We need to address all networking and these kind of things that we weren't. And a startup usually isn't particularly a technical startup isn't well versed in these kind of things. So support on this level, perhaps on a more business level than the technical level, because we think we know what we're doing there. That's the kind of support, that networking support, again, financial support, of course, but marketing support and these kind of things. It's certainly what would be useful to us. Yeah.
But your main competence is the technical one, and you would need help in business marketing.
We have done. We've had some good support from our business in the Canton of Vaud. We've had good support from Innovo, who've helped us network, helped us find investors, and this kind of thing. And those kind of initiatives on the cantonal level have really helped us, I think.
Okay.
And that's been useful for us because it's something we didn't really wasn't our core competence at the beginning.
Of course not.
It is now becoming that. But
you were an electronic genius and not a salesman.
Yeah.
Big Thomas, you.
Yeah, I just wanted to comment with respect to that. One of the things that we recognized when we set up the National Center for Competence Research in Planets, led by Willy Benz, was the need to have a sort of a technology platform which would assist companies in trying to assisting startups or looking to at ways in which we can exploit new ideas, new technologies. And part of the thing that we've done within this technology platform of the NCCR is to support a thing called Swiss Company Maker, which also invites experts in to support people that have new ideas and would like to start up a new company. It's absolutely true, at least from the experience that I've had with this process, that young people, those people coming out of university who are just involved in maybe have just got a new idea coming out of the research that they've done, they have relatively little idea about business and about how companies work. The fact that you've got to fund, the copy machine. It's all done for you at a university. You don't have to pay for it. At least I pay for it. I sign as director for the copy. But when you've got your own company, you have to do everything. And learning about that and learning about that process and bringing things up to a level where you can start as a startup. Learning about that, I think if there are, you're asking about what can be provided. I think these are the types of things that people need. They have the ideas about what they might be able to sell. Otherwise, they wouldn't be thinking about making a startup. But they need help with things where they're lacking in knowledge, and that's an area often where they're lacking.
Yeah, I think, and as we grow as a startup, the 5 guys who began building a satellite suddenly become financial managers and managers of the company, and we're much less involved in the actual technical building of a satellite as well. So we need the universities to provide the next lot of people that we can tell how to build our satellites as well. So I think this embracing these kind of technologies in universities, like the EPFL, for example, we need that as well, because we need the next lot of people to come in.
Yeah, I think maybe
we take your contribution, then next your question. Huh?
Maybe to the part of also Astrocast, they were a bit unfortunate because we started since last year. We have a program which is called the Business Incubation Center, which is done together with the European Space Agency and is accessible across Switzerland and gives this kind of support. I think you were just a bit too early with, with respect to that, which certainly would have helped in the beginning. So I think that aspect has improved a lot the last few years. So to my recall, I think we're about 10. We have 10 companies which are now being funded within this program, and so it's we're really improving that. But on the other hand, how do we bring new companies to Switzerland, and how do we bring the right talents, or we train the right talents? I think Julian mentioned that is something we still certainly have to work on. How do we bring in this talent and make it available for the industry?
Can we get your question, please?
My question is mostly for Thomas. So in line with the vision you presented, NASA is already thinking about the successor to the James Webb Space Telescope. And these are LUVOIR, HabEx, X-ray Explorer, and the Origin Space Telescope. It's interesting that 3 out of 4 of these missions have as one of their primary goals the detection of life on exoplanets. The obstacle that I hear being whispered about in different circles is that the price tag is going to be upwards of $10 billion for the mission. This seems to be well beyond the appetite of what the combined budgets of the space agencies can handle. So I have 2 questions. One is, what are your general thoughts on the selection of these 4 missions going forwards? And what do you think of the budget?
So the successor to James Webb is WFIRST. It's something that we're working on right now. It's a mission that's basically 100 times the Hubble. So it's basically a spacecraft that's looking at both dark energy related topics. One of the key contributors to the energy in space, therefore has a larger field of view, and also exoplanet type of topics. We're struggling with that, trying to figure out how big it should be. And so kind of the same topic. See that if you took every telescope that we've ever built, and not just we, I mean, we, all of us, ESA, NASA, and you drew it up. What's really interesting, if you took on the x-axis the diameter of the mirror, the primary mirror, and on the y-axis the cost, there's a curve that fits through it almost perfectly with an exponent 1.8. So cost is proportional to the diameter of the telescope to the 1.8. Okay, so you take James Webb, 6.5 meters, right? Is the mirror, the primary mirror. Okay, so it's 8 billion. I think we could have done it for 5 if we don't want to be as cold. Just take 5. Give me that, okay? I don't know whether 5 is right or 6. I don't know, but it's not 3, but it's 5. Okay, so you go and okay, I'll take 5, but I go to square instead of 1.8 because I don't have a calculator. So basically it's t squared, right? So you basically go from 6.5 to 18 meters, which is what you guys are talking about, right? You get the point. It's kind of 3 squared. It's a factor of 10. So it's going from 5 to 50. It's actually not 10. It's larger. So the trick of these studies for the one after WFIRST is to go break that law. So we need to, we cannot forget it. We can remember the rules of constraints. I'll give you the constraint that it cannot cost that. So figure out how you fix it, right? We cannot go the same path that we go with the regular telescope. It is not an option. It's like, and frankly, it's a simple reason for it is we may be able to build one more telescope, then we're dead. Because afterwards you can't do anything anymore. So let's go figure out how we fix that law. We have to beat down on that law that has dominated what we're doing, and somebody has to investigate. Kind of somebody who's smarter on the technology of these mirrors and so forth than I am has to investigate what creates that law and how we can beat it down and kind of get on a different kind of trajectory. So that's what I would say. So it's good to kind of figure out what the science is of LUVAR or whatever they are, the ones afterwards. The Academy will prioritize it, but I can tell you already now, we're going to have to beat that law. So there's kind of, between now and then, some kind of important insight on innovation has to happen. Otherwise, that is the last telescope or the one afterwards. It's just, we have to get off that trajectory.
The microphone to Rudi von Steiger.
Thomas, that's very interesting. I have a follow-up question in that respect. As you know, I'm tasked with, 2 of us were tasked with COSPA to think about scientific use of small satellites. You left, I think, for good reasons, but I'm still stuck with it. Now, thinking of the next generation telescope, you gave us that law of aperture to cost. We have to break that law. We agree. Do you think one way of breaking it would be to break the mirror, to break the telescope, make a synthetic aperture telescope of small satellites with phased together inputs?
I think it's a perfectly good hypothesis. The point is, we cannot fly spacecraft that well. Now, what we're doing with LISA, we're learning how to fly spacecraft really well. Now, it's too expensive to use the LISA technology, so we have to. So, the way you do it, it's just like we said, identify where the problem is. Now, start kind of. I think this is a perfectly good way to go down that trajectory and see whether it leads to an end. I don't know. I don't think anybody knows, right? But that is one. Another way, by the way, that is out there is to kind of see whether human interactions actually could help. Often, human interaction makes it harder, but if space manufacturing is another one. What are the things that we could use, kind of technologies that are just coming on board? You see 3D printing basically taking off with metals, right? What we can do, what we can print today is incredible. Even 5 years ago, we can print today in metal parts that we could never do 5 years ago. We couldn't even dream about it, right? And so basically you look along that trajectory and basically say, well, if we had a 3D printer in space for some of these things, like, can we get to that trajectory? So for me, look, between us, we just put like 4 hypotheses on the table. None of us knows what the right one is, but the work that needs to happen is to push along these trajectories and kind of figure out which ones are dead ends and which ones are roads to the next future. I don't know.
But in general, do you see a future for a business like Julian Harris for small, very small satellites? Or is this just a...
No, absolutely. I mean, you know, Planet is a business in the US. They just launched something like 80 spacecraft, what is it, 3 weeks ago? Yeah. Right? And they have, you know, it's basically an imaging. Look, that company is basically a data company. You know, so it's basically so they're just going to space because that's where the data are, you know, but they're basically, it's a data company that they sell knowledge. So basically at any one point, you know, if we could see those spacecraft, there's multiple of them in the sky right now, you know, that they're basically flying by and taking images. They only have 5-meter resolution or so. The standard for kind of, but if you want to sell data right now, Earth imaging, the standard is 0.5 meter, you know, the French Spot mission and other missions like that. If you go below that, it becomes kind of military stuff, but or, you know, typically, but 0.5 meter is basically what you need. You see every house, every road. And so basically, but 5 meters, I mean, I just talked to the founders and they're really seeing business pick up. So there's people who are getting that data. So I think the communication space is going to take off really quickly. There's like, whenever you have like, you know, it's kind of frustrating if you're the startup guy, but if you look at it from afar, you never want to be the only guy in your space because almost certainly it's not that hot. Because if you're the only guy who sees that there's any dare there, you know, perhaps you're, chasing a fantasy instead of a real market. It's kind of my point is there's like, you know, a handful of companies in your space that looking at communications. And I think the communications space is really taking off. I think small spacecraft is exactly where it's at. How exactly that the size will be and what the market niches are going to be, I'm going to be interesting. You know, is this market shipping? Is his market actual internet communications? Probably I don't know. I mean, kind of for me, the way I think about companies always, who's my customer? Who's the customer I'm delighting? That's the first thing I ask, and then I figure out what I build. And you know, so for me, small spacecraft, I think there's probably a handful of companies that are. The investment in small spacecraft last year is between $1 and $1.5 billion worldwide. That should tell you that other people think there. Yeah. Mm-hmm. And so basically, I think it will take off, but it's an early phase. You know, kind of what happens is a bunch of these companies will not make it. The ones that are invested in, but some of them will. I'm convinced because we already see examples.
It frightens you, or it encourages you? What Thomas said.
It
some will make it and some will not.
Well, but that's a risk of business. You've got to take that. You've got to learn to fail, right? You've got to learn that, and you can't be. If you were afraid to fail, you would never do it in the first place.
You see your customers.
Yes, we do, and that's one thing that we've been quite strong in is looking at the needs and the niches of where we can use our small sats, and how the small satellite costing and the low cost fits into the market. And that's one of the things that we've been quite strong on since the beginning. Really. Yeah.
And the best guess, when will you launch your 64 cubes?
Let's say in phases. But the first 2 will be mid to end next year. Yeah.
But 2 cannot do much.
We can do business.
Yes,
absolutely, because we're launching polar orbits, so we have a global coverage. Okay, with 2 satellites, we have a slightly slower latency, but for machine-to-machine technology, we're not targeting high-speed video data or imaging data. It's just small data for machine-to-machine technology. We don't need live data. The more satellites we have, the better the latency, the lower the latency is. But we can do business with anywhere more than one satellite.
Okay.
Do you mind if I jump in just to tell you a story that? So, you know, in my previous life as a professor, I worked often with companies, including companies, you know, startup companies, and one of the elements we were really interested in is bring internet to Africa for the reasons you work, right? Kind of to connect medically, cities, to provide information, to learn about it, also to kind of enhance, the quality of life there. And I worked with Google. And it was really interesting. So we started and we basically came up with a constellation of spacecraft. At the end, Google invested in a constellation based on the work that we did. But we realized to actually try out the market, we could use excess capacity of some geostationary assets without having to build. So we could so our hypothesis was, people will use these data. Well, we could go try that without ever having to build a spacecraft, just by giving some money. We overpaid compared to what we needed at the beginning, but it gave us confidence in the market, and so that's what happens if you focus on the customer first and, kind of don't fall in love with your technology too much before you understand your customer, is you can try out and really learn about that customer behavior before you make all the investment. And frankly, it will attract the investment, basically, because you basically have rules like, look, I mean, I provide this data, I can sell it there. The bottom line works. So now, an investor says, well, the risk is a lot smaller now.
They're not okay, but where do you see the opportunities for science, for research with these small satellites, cube satellites?
Well, I think the opportunity for science is that you can have large distributed systems for a very low cost. I mean, I think that it's you have to think different in a sense. You maybe not. I think there was Rudy proposed. I mean, why not make a big mirror out of CubeSats? But that's the type of thinking you need to start doing. How can I use, instead of having one large satellite, how can I use a lot of little satellites to do some science with it? And I think that's the challenge, and also to the scientists to come up with good ideas. Do we do atmospheric science? Do we do some groups are even talking to do planetary science with it? I think you guys are planning something in that sense. So so there is a lot of opportunity out there, but it's definitely the market is there's a bit of change going on. I mean, we go from these very big satellites, which we will still need them in the future, to having a new class of smaller satellites, also the way they are approached. You can manufacture it in a more industrial way. If you're talking about hundreds of satellites, you will not have the same manufacturing costs as if you're talking about one or two satellites. But both of them have their own merits. And if you look at the communication or telecom community, there's a lot of people trying to understand where is it going, and I think at the end we might see actually both in the marketplace.
So you definitely see the opportunity for the researchers. Yeah. We have 5 more minutes, and we can have some questions from your side. Lady again.
Sorry again, but this time I have a more operational question, and actually I don't want to feel restricted. I want to have your opinion. Imagining the future, all these spaceships and satellites flying around. Right now, there are no regulations about space traffic management. And I would like to know, and I have certain sources, and I know in the States as well, we are not further than in Europe in terms of trying to find a solution. I know there are a lot of initiatives. I don't know if they come bottom up or what's happening. As you know, coming back to Switzerland, we are the only nation in the world having a totally integrated civil and military air traffic management. So my question is, how can we all collaborate, and what would be the solution for a common space traffic management?
As you said, it's a hard problem, right? So let me give you an analog. So the way we deal with oceans is actually in a really good way. So it's going to pass as we, within, international regulations, there's certain waters that are international. There's certain rules we accept on this, and basically every country accepts it. And if the country steps out of it, they get beat up by all the other countries, right? So there's a standard that was developed and it was implemented. What happened in the I think we're close to 10 years late now. So kind of the previous administration in the US really didn't want to talk about these regulations for space for whatever reason that I wasn't, really privy to all the discussions. But I think we need a similar type of approach to that, a similar kind of a set of rules. We have some rules that we're using, for example, for certain orbits, there's a 25-year orbit limitation. So in other words, no matter what happens, within 25 years, you have to be out of the orbit. So we will not get launch approval in the US if you're not doing that. But kind of the step, where is the right level of integration? Where's the right level of international alignment, I think is up for debate. Kind of, generally speaking, you don't want all elements to be regulated, just because, frankly, we just said, kind of there's so much differences between various, international contributors. You put China on the table, with Europe and the US and, other national, Luxembourg, kind of people, newcomers that have tremendous aspirations. It's important to kind of really struggle through what the right level of regulation is, but really implement something. I think we need to. In the absence of that, I think we have a problem on a time scale of 10 years or so. I mean, kind of right now, we know what the issues are. We know where they are. But I think on a time scale of 10 years, suppose everything happens that people say they want to do, okay? Or even half of what they say they want to do happens in 10 years or so, we have a problem with orbital debris, with kind of overloaded orbits. And that's a real challenge. And so for me, I worry about it just like you are. I just think there are analogs and we need to learn from them, as opposed to, just basically throw up our hands.
So we take one last question.
Thomas, here's the challenge. Assume the following situation. Tonight, amateur astronomer detects an object, and together with serendipitous observations from Palomar in the 50s and somewhere in between, we realize that this is an asteroid of the class that wiped out the dinosaurs, which will impact the Earth in the year 57 with a 85+% chance. What do you do?
The first thing I do is I'm really surprised because the sizes of the asteroids that you just described, kind of a kilometer or higher, we're actually we know well over 95% of all the objects now. We have done, it's closer to 99. And then we basically know pretty well where they are. There's certain segments in the sky, kind of out of the solar direction, if you want, that are not that we don't fully understand. The comets, that made big news last week, they're less than 1% of the threat. Kind of the other threats are a lot higher. Where we kind of at the 140 meter, and so we're close to 60%. So we're not there yet. What I would do in a case like that is, it's really funny. Actually, this week we're running a practice run in the U.S. government with some international contributions as well, because we have an object flying by. And so basically we're going through the alarm kind of mechanisms. So what we would do is try to figure out right away where it would hit and kind of evacuate cities if that was the case. Kind of, if you hit anywhere, the likelihood of hitting a city is really small. And just go look at the globe, throw a dart against a map. You realize it's not very high, but just because there's so much ocean and other things. And so we would evacuate the cities, would be one of the highest priorities. If we had decades, we would want to think through the various opportunities, the various options that we've developed over the years, some on paper and some real, to deflect the piece. So this is the first time in history we have a chance to deflect, right? But if it's really on collision course and right away coming towards us, the first thing we're going to focus on is saving human life, and then gamble for the rest. right? If it's really wiping out, the entire atmosphere goes dark or whatever, it doesn't take many degrees to really make a huge change, right? This one will be cooler, right? So basically, if it solves another problem, I guess, but so if. But if it did that, right, we would focus on a short time and then really immediately go to work with the international community to really figure out what the longer game is. But it's one of those things that we know will happen sometime. Just history tells us the Earth is, well, the moon is full of craters, and the Earth would also be if we didn't have erosion and continental geology, right? So there's less of those. So it will happen. The only question is when and how.
So I'd like to close because I'm hired to handle the time management too. I've learned that space offers opportunities for business. It offers opportunities for research, also problems or issues for coordination, that research. I learned that we have to regulate, for example, the how and who can use the orbit, but I've learned that we are thinking on regulate this, and I've learned a little bit of science fiction, that if that big thing is coming, perhaps we would go up and, like in Armageddon, we would dismantle it, or give us some decades to think and look who will be hit. Hopefully water or North Korea, I don't know. It's unlikely. Okay. Many opportunities, many things to do, opportunities for you as a researcher. Satellites or space ships are getting smaller, cheaper, new opportunities, new ways of thinking. Splitting a big lens into many small lenses, as an example we heard. And I think this is a good feeling to say, yes, space is waiting for us, as it did, it will do, and we will take the chance. Thomas Zurbuchen, thank you very much for giving us that insight, also from the personal view. Nick Thomas, thank you for participating. Renato Crepon, thank you for taking the opportunity to give us some thoughts of the Swiss administration. And Julian Harris, thank you for giving us that optimism to get the business to fly into the orbit. I wish you all the best for the future. Thank you for taking part, for paying your attention to our discussion. And I hand over now the microphone to Marcel, who will give a short ceremony for the winners of Swiss of two contests, Schweizer Jugend forscht and the Swiss Physics Olympiads. And you will make the small ceremony, Marcel. And again, we give you a warm hand for your contributions.
So here's sitzen.
Also, before we now start this ceremony, I would also like to say, you see, I mean, this was very stimulating this morning, and many fields were touched. And I was personally saying to thank not only Thomas Zurbuchen, but the whole panel. They have already disappeared into the ranks here, but really this what we learn here. Now we explored the space and we looked at these the prospects and whatever. In my work, and thank you very much for referring sometimes to what we do in health development and looking for rare diseases, for neglected people, neglected diseases, the principles of the 5 steps are exactly the same. And I think this is really the thing. It's also the enthusiasm, even if you deal with difficult things, with worrying things of our world. All those who are only politically discussing how it's all complex and difficult and so on, they never discover anything. They never do anything. It's the enthusiasm, the drive, the joy to discover, the joy to share, and the joy to translate something into action. So thank you very much for this. This gives us a lot of stimuli. And when I talk also to the people in our field who too often drift into this complexity and difficulty and social political context, forget that innovation, change, and also that we can overcome poverty and that society can be changed is really depending on your 5 steps. Thank you very much. And that's important, we have also the mandate in the academies to stimulate really science and this joy to discover, this joy to share in early age. Not only at the university, at the end when you hand over the degree to say, now it's your time, but very early. And that's why we have this process of Schweizer Jugend for, Swiss Youth in Science, or whatever the translation is. And we have actually in the high school, in order to stimulate first steps in science and to really show that at all levels of your age, you can be creative and innovative. As well as we have very specific in physics, we have this, or related fields, we have the Physics Olympics, Swiss ones, and then is the international level. And today it's wonderful. We can now, and we take this opportunity. It's wonderful that Thomas Zurbuchen will hand over these diplomas. We have these special moments to honor some of these achievers. And now we start first with the Swiss Youth in Science situation. And I would kindly ask now that actually Rebecca Hamm could come forward. Where is Rebecca? Here is Rebecca. Now just, oh, she is already coming with a very interesting, she's Swiss Youth in Science, and she has chosen to go into the world of stratospheric balloons and has produced outstanding work. She comes from Stans, from the Collegium Fidelis, is that correct? And she has chosen to go high up, I don't know, inspired by Picard or whatever, and before. And we are really very happy to see you not only having this, this achievement, but let us please tell us, why did you jump into the stratospheric world?
Yeah, I think that's not so fascinating. I only saw some videos on YouTube and I thought, yeah, I want to do this also. And since then, I only wanted to let go a balloon in the stratosphere, and I did it, and it was amazing.
It was amazing. That's your joy. Yeah, that's very important. Yeah, joy. That is very. So we congratulate you very warmly for that, and you now have also the diploma. That is now Thomas. Maybe you will also would like to talk with a few questions, not too long, with Thomas Zurbuchen. Yeah.
Look, I mean, first of all, I really think it's great that what you're doing. I think it's a wonderful start, and I really commend you for this. You know, I just really hope it's a beginning of a career that makes you more and more excited about this. You did, you know, this distinction here is given to you for your outstanding experimental study of 2 stratospheric balloons, you know, Stratosphärenballon and Blick über den Horizont, executed in a framework of Swiss Youth in Science and European Space Camp in 2017. I'll ask one question. Let me just tell you what happened. So last week, you know, the gym shoemaker On, somebody may have On, you know, a Swiss company that builds shoes, running shoes from Switzerland, called On, E-O-N. They contacted me and said they want to bring one of their shoes to space. You know what you should do is contact them and say you'll fly them if they pay you $20,000. And you take an image. Could you do that? Could you fly a shoe?
I don't know. Maybe I could try it.
I think it would work. I think, you know, so their slogan is, you know, to run on clouds.
Yes.
And so they need to have clouds too. So if you fly it, take a camera. Did you have a camera on your balloon?
Yes, I had one, but I couldn't have a photo from 32,000 meters because the safety place was too little.
Yeah, that's right. So you had to turn off.
Yes.
You had to turn off this. Well, I mean, for most of the balloons that I've ever done, it takes me like 1 to 2 attempts to get them right.
Yes.
And so we actually just, you should know, just last month we crashed a professional balloon because we couldn't get it to work. So don't feel bad. Just do it again. And I'm really, I want to give you this and congratulate you very much. I brought a little bag.
That's from Professor Rudolf von Steiger, Institute Director of History. Congratulations. Yes, congratulations, and keep it going. Yeah, thank you very much. And now we move to the Olympics, the very special one. And I must take now the notes. I don't have all the names. I would like to ask Adrian Rutschmann, Henning Chang, Tamar Somm, and Pascal Isering to come forward. These are actually the participants of the Swiss Physics Olympics, and they got the gold medal. And yes, the gold medal. Not just any medal, but the gold medal. And then, because they have the gold medal, they could go to the International Physics Olympics. And this was, I must read. So this actually took place in Indonesia. So you have been in Indonesia with 420 others, or let's say 416 others from 88 countries together. And there you had a 5 hours exam. And it turned out that Adrian Rutschmann got a bronze medal at the International Olympics. Henning Chang got his also a bronze medal. And Tamar Somm and Pascal Isering, they got, with the gold medal from Switzerland, they got in the Physics International one, the honorable mention. That would be something in the Olympics up to rank 8 or something like that, you see. That would, so all medalists. And we congratulate you warmly. And you may also have maybe some personal impressions and why you actually embarked on that. And I would like to hear from each one a short statement. I mean, not just to come here, get the diploma and run out again, but a little bit a personal remark to this achievement.
Yeah.
Just the first reaction. Just you can say, I'm happy. That's all.
Yeah, but I'm happy because it's in the field I like. I like physics, so I'm happy to achieve something in this field.
And these 5 hours exam, that was very tough? Or was it really, did you feel a competition, or were you just thinking on your own, or how did you feel about that?
Yes, I think 5 hours are it's a lot of time, so sometimes it worked. It was a great feeling because I could solve something, but there's other times I couldn't manage the solution. So in the end, overall, it's a good thing. But
yes, and you are smiling. I like that. Yeah. So let's move on.
Yeah, it was a nice experience to be in a competition of a topic that you really like and achieving something and getting home. For example, like me, an honorable mention is a nice feeling.
Yes, that's more than a nice feeling. I think you can be very happy. And but moving on a little bit different, how was this collaboration with all the other 400 colleagues?
Yeah, it was really interesting to meet people from around the world, and everybody's interested in physics and everybody likes about the same stuff as you do. And it's also interesting to see that people are not as different as I thought. It's like, yeah, you don't even notice if they are from the other side of the world sometimes.
That's hope for our world, isn't it? that we can move on together. So very good insight besides the medals. Yes, and
yeah, I think everything has been said. It was really an awesome experience, and I'm happy to, yeah, to have been there.
yes, and congratulations to all of you. And here are the certificates from Thomas Zurbuchen, as well as the bags, the NASA bags with more inspiration.
So I mean, again, congratulations to all of you. I'm going to walk by, give you the certificates, and kind of read your citation. The one thing I want to talk about, physics, I just think it's such an important subject. And the reason it's so important is that, first of all, it's a launch place for so many other careers. You know, and I was reminded sitting here that of my colleagues, 3 of them have companies now, startup companies that they started from scratch, my physics colleagues here. Some of them are in companies elsewhere. Some of them are doing research. Some of them are professors. Some of them are in careers, and none of them is unemployed, right? Kind of, I mean, this is what happens with so many of these science careers. So that's the first thing I want to say. I want to add one more point to it, and that is physics is one of those fields that if you do research, it changes what we know, but sometimes it changes how we think about life itself, about society. Some of these things we do changes how we think totally, right? The Copernican revolution. It went from something where the Earth was in the middle and so forth to something where the sun was in the middle. It changed how we think. Imagine all these discoveries you could make that changes not only what we know, but how we think. So that's what I wish for you. And you made a good start already. You're Adrian, right? So I want to congratulate you for your gold medal at the Swiss Physics Olympiad and your bronze at the International Olympiad. Congratulations. Come on. Pascal is in the ring. I want to congratulate you for your gold medal at the Swiss Physics Olympiad and your honorable mention at the International Olympiad. Congratulations. You come on. I want to congratulate you for your gold medal at the Swiss Physics Olympiad and the honorable mention at the International Physics Olympiad. Congratulations. Henning, right? Congratulate you for the gold medal at the Swiss Physics Olympiad and the bronze medal at the International Olympiad. Congratulations.
With this, you can go back to the rank for our last step. And thank you again. And thank you again, Thomas Zurbuchen, for the honor that we had to have you with us. And I hand now over to Professor von Steiger for his closing remarks. Is that correct? Yes.
Thank you very much. Put the name right. So I completely realize that I'm the last guy between you and the next sip of water, or our little lunch, which we have in a few minutes just downstairs. But before we get there, let me address just a few words to you, especially words of thanks. First of all, I would like to thank all of you in the audience. It is a very good thing, and it's a very good sign for the Swiss space science community that we get almost 100 people together on a almost holiday, the 2nd of August. So thanks for coming, and thanks for making this event such a successful one and an interesting one. Thanks to all of you. I would like to thank also in particular my colleagues from the Astronaut and from the academies of Switzerland, Marcel Tanner, Claudia Appenzeller, Jörg Pfister, Roger Pfister, and everybody who was involved in the preparation of this. It was a particularly fitting experience, I think, because as of this year, my institute, ISSI, our institute, is funded partly no longer through the Swiss National Science Foundation, but through the Swiss Academy, the Astronaut. And I think this gave us a great opportunity to get to know each other a little better and to show that we can really team up and make something happen in a relatively short time. So with this, I would like to go to ISSI and thank my ISSI colleagues for their help in the preparation. Andrea Fischer, Saliba, with the computing support and the webcasting, all this, everything you said and is webcasted and can be retrieved afterwards. So thanks to all of you from the ISSI to make this happen and for the preparations. Finally, I would like to thank the panelists. Thomas, to you, I come a little later, but let me start with Nick. You get a little token of appreciation. And Nick, thanks for making this interesting discussion. I think you're the only guy, apart from dressing up as Ziggy Stardust, to throw carbon dioxide at me, and actually hitting me.
And I didn't do it hard enough, obviously.
Thank you, Nick. Thanks. Next, I would like to thank Renato. You are a very important guy, not only for Swiss space science, but in particular for ISSI. So thanks, Renato, for coming here and representing the Swiss Confederation in this panel. And let's look to a good future together. Thank you, Renato. Finally, and I was very happy to make to get to know Julian. Thank you, Julian, for coming here. Thank you very much. I learned we have a lot of common ground in the past with Andre Balog, who Thomas, of course, also knows very well. And I was very interested to learn about your rock experience, so I'll certainly look you up on YouTube and hope to find something there. So thanks for coming and thanks for making it interesting. So finally, Thomas, to you. Thanks, first of all, for telling us way ahead of time that in the early days of August you would be in Switzerland, and why don't we put something together. You gave us the chance, the opportunity to team up between the ASCINAT and ISSI in the building of the university. So I think the three players come together here, to which you gave the opportunity to excel and to make this panel and this event happen. As you know, we go back a very long way, and the first clear recollection I have was when you were a young student at the university in the coffee Friday night with some bad wine and other stuff. I played a practical joke on you. You remember? Of course you do. I would have thought so. I went to another telephone in the room. I called up the coffee room with a dislocated voice. I told it's the fire brigade from Heiligenschwendi. Not the observatory, the sanatorium is on fire, and fireman Zurbuchen is ordered to immediately come up and help fight the fire. Unfortunately, the telephone gave me away because it had a different ring from the inside than it would have had from the outside. And it took Thomas maybe 20 seconds to realize, but these 20 seconds, I think you were horrified. What this story tells me, it's not just a joke, it tells me were serving the community. As a fireman in Heiligenschwendi, as you are in many capacities in between, as you are today at NASA. This is a service to the community. I know you took a significant salary cut from your professor career. You could have had other careers, I'm sure, with 10 times or much more the salary. No, Thomas, you are the guy serving the community. And I think we owe you huge thanks for that, for what you have done in the past and what you are going to do in the next years. I witnessed you at the AGU last December, and I think I could feel ein Ruck ging durch die Gesellschaft. I could feel a shake-up in the scientific community. It was for the first time in many years that the associate administrator had addressed them in person at the AGU. I would be hard-pressed to give the names of your predecessors less than 20 years ago. And because they have not shown up at the AGU, the guys behind them, of course, were very instrumental, Dick Fisher and others. And so I think this gives us very important sign to the community, and you gave it to us. And one thing you said there was, because that was the time right after the election, the presidential election, there was big insecurity, which is not over, I understand, but there was big insecurity and there were questions to that extent. And your answer to that was, don't amplify noise. And I think that's another characteristic of you. You're not an amplifier of noise. You are quite the contrary. You are a filter for noise. And when it comes out through your mouth, I think things become clearer. And I think that's a big quality which you have and which you give back to the community. So thanks, Thomas, for serving the community. I hope you will serve the community for many years to come. I know the insecurity in your business, in your job, but let's hope it will be for many years to come. One of your predecessors is on the record by saying that, well, it's a hard job you have, and it's a job you might even lose friends. And he said, well, in this job, you lose something like 10% of your friends. So after 5 years, you have to leave because you have more enemies. You have lost more than half of your friends, and that's not a good situation. I think you can do better than that. I think you can cut that number down to 5% or even lower. So let's hope, Thomas, that you are in a very good position to serve the community via the NASA Associate Administrator job in the future. And if anyone, I think, if you ever get the chance to talk to the president, you would be the one to convince the president of the reality of global warming, if anyone could do that. So this is as close as it gets. Now, Thomas, thank you for everything. I don't give you this goodie bag because I know you don't want to be loaded for the trip home, so we cut down on size, not on value, I hope, but this is a little token of appreciation from the SC-Not and from ISSI. Thank you for coming.
Merci vielmals.
Merci vielmals, Thomas. And with this, all remains to say and do is to officially close this event and invite you to a little stand-up lunch mixed together. Thomas, I think, will stay with us for another hour or so, and mix together and chat and talk and have a good time. Thanks, everybody, for coming. The event is closed.